This is going to be an explanation of the outfielder problem. We're told that an outfielder throws a 0.15 kilogram baseball at a speed of 40 meters per second at an angle of elevation of 60 degrees. What does this mean? It means that the ball is being thrown in this direction. The speed is 40 meters per second, and the angle compared to the ground right here is 60 degrees. So we're told the speed and what direction. Now when we're thinking about energy, energy doesn't have a direction, but the direction of the velocity is going to change over time, and we need to be aware of that. I can always take a velocity and break it into two parts, one part that's completely vertical and one part that's completely horizontal. I'll call the horizontal part Vx and the vertical part Vy. I could draw Vy over here just as easily, and you can see when I put these together, I get a right triangle. We also have convenient functions for writing the size of these. The adjacent side of this triangle compared to the hypotenuse, it'll be the hypotenuse times the cosine of that angle, cosine of 60 degrees. That's all that cosine means. It's the number I multiply the hypotenuse by to find the adjacent side. Vy, you might guess, is going to be 40 times the sine of 60 degrees. This is what things look like when the ball is first thrown, but we want to see what happens over the course of the ball's motion as it moves toward the infield. So let's take a look at that. We have a simulation here. I wrote this in Python. And the ball is moving from the outfield towards the infield along this parabolic path. Let's watch the components change over time. Here's the horizontal component in green, and is it changing? There's no force in this direction, so that component never changes. But the vertical component does decrease. It slows down, as any object does when it's moving up in a gravitational field, and the direction of the total velocity is approaching horizontal there. At the top of the motion, the ball is only moving horizontally with this size of velocity, which was determined at the start by the angle that we launched the ball. So at all of these points, the horizontal part of the velocity is the same, and here it is the only part of the velocity that still exists. Vx is v0 times the cosine of the launch angle, and here our v0 is 40, and we know our launch angle is this very convenient 60 degrees. So that is how we think about this problem. We want to know the kinetic energy at the top, and it is only the part of the energy that carries the ball forward. That is a special property of the top of the motion here. So I hope that helps in thinking about the outfielder problem.